Good afternoon, class. Obviously, I am not here, but what I need you to do today is to, while we are taking attendance, to come up with the probability of each of these events. Please pause the video, take attendance, and when the students are finished, I will have the answers for you. Again, we're rolling a dice here with the numbers 1 through 6 on it. So we're rolling a 5. There are 1 5 on that dice, and there are 6 total. So our answer is 1/6. When we roll an even number, there are 3 of those. 3 out of 6 gives us 1/2. Rolling a 3 of 4, there are 2 out of 6, which is a third. Rolling a 6 is similar to the 5 because we have 1 of those. Rolling a 1, 5, or 6, there are 3 out of those 6, which is again a half. And finally, rolling an odd number, 1/2 as well. Friday, we did a few problems, so I'm going to put those answers on this slide right now. Here are the answers to 6 through 17. 6 is likely. 7 is impossible. 8, certain. 9, unlikely. 10, equally likely. 11, 1/10. 12 is 1/5. 13, 9/10. 14 is 4/5. There is 0 chance on 15. On 16, the student found the probability of using the blue shirt. The not blue would have been 6 out of 10 or 3 out of 5. Number 17 is 20. And then our last one, we had the number of winning ducks over the total ducks. So 0.24 equals n over 25. When you solve that, we get 6. So the number of winning ducks is 6. So there are 19 not winning ducks. 19 not winning ducks. So the 19 goes on top over the 25, which will give us 0.76. Because it's 0.76, you will say that you will not choose a winning duck. It's likely that you will not choose a winning duck. Today we're going to talk about how to use relative frequencies to find probability. We're going to actually talk about 2 different kinds of probabilities today. The first probability that we're going to talk about today is experimental probability. It is a probability that is based on repeated trials of an experiment, and what we do is the probability of something happening is the number of time that event occurs over the total number of times. So in our first example, this is rolling a number cube. The bar graph shows the results of rolling a number cube or a dice 50 times. What's the experimental probability of rolling an odd number? So the first thing that I have to do is I have to look at these odds. There are 10 that are 1 that were rolled, 8 3s that were rolled, and 11 5s that were rolled. So the first thing that I know are there are 29 times that we rolled an odd number out of those 50. So we put that in. The total number of times that it occurred was 29 over 50. And that is our probability. If you want to change it into a percent or a decimal, that is fine, but you can also leave it as a fraction. In a similar thing, it rains 2 out of 12 days in March. If this trend continues, how many rainy days would you expect in April? So the first thing that you need to figure out is how many days are in April. And there are 30 days in April. So the probability of the number of times a rain will occur out of the total is 2 out of 12. We can simplify that, if you wish, to 1/6. Since we know that that's the case, we must then again use the days in April, which we know there are 30. So we take 1/6 of 30, or we can go 1 over 6 equals x over 30. There are 5 rainy days in April that we would be able to predict. Our second type of probability is theoretical probability. This is when all possible outcomes are equally likely. The theoretical probability of an event is the ratio of the number of favorable outcomes to possible outcomes. This is pretty much what we talked about on Friday. Favorable over total. So in this example, we have the word explorer up here. You randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So our probability is the number of favorable outcomes over the number of possible outcomes. There are 3 vowels, the E, the O, and the E. Even though there's 2 E's that are the same vowel, there are still 2 chances to choose that. So we've got 3 total chances out of the 7, which will give us 3/7 or about 43%. In this example, the theoretical probability of winning a bobblehead when spinning the prize wheel is 1 of 6. The wheel has 3 bobblehead sections. How many sections are on the wheel? So we know that the bobbleheads over the total. We know that 1/6 equals 3 over S because we don't know how many total sections there are. We can then do our cross multiplying and we get 18 sections on that wheel. Our final example deals with experimental probability. The bar graph over here shows the number of times rolling a number cube, and we rolled it 300 times, and you can see the results. What's the experimental probability of rolling an odd number? Again, I need to find out 48 ones, 53s, and 49 fives. So when I do that, I add them up. There were 147 out of 300. So our probability is a 147 out of 300, which is approximately 49%. Now, what they want to know is, how does the experimental probability compare with the theoretical probability? Well, we would expect these all to be rolled evenly, so there are 3 choices for odds out of the 6. So our probability for that is 3/6, which is 50%. So it's really close to what we know. So again, the differences that we've talked about, theoretical is in theory, if everything is equal, it is the total number of favorable outcomes over the number of possible outcomes. Experimental is the number of favorable times it occurs over the total number of times it occurs. So for the rest of class period, I would like for you to complete pages 417 and 418, problems 6 through 22. I will be putting those problems up very shortly on my video. You can pause the video when those come up. These are the questions for problems 6 through 14. You can pause the video to allow students to work on this. And when you are ready, you can restart the video and I will have the rest of the problems for the students. Here are the rest of the problems for 15 through 22. When you are done, please get something quiet to do the rest of class period and have a great day.